consider about the power signal. Consider a periodic signal. You can already know what is a periodic signal. The characteristics, recall that the characteristics of a periodic signal is like that. That means it is continuous with respect to time, and its shape or its value is repeating for after a particular time interval. The signal shape is repeated after a particular time interval. If this characteristics is shown for a signal, it is a periodic signal. It is already discussed in your previous class. Here I am just recall the concept. So consider any periodic signal. Its cycles repeat over the time, and the signal amplitude of this signal does not become zero as t tends to infinity. Hence, the energy of this signal will be infinite. So, for a periodic signal, the signal amplitude represented as A. It is a signal amplitude. It not becomes zero. It not becomes zero. And as mod t tends to infinity. That means when time tends to infinity. That means the signal amplitude does not reaches zero position when t tends to infinity. See the signal. This signal is continuously repeating for the total time interval for a periodic signal. Total time, this is minus infinity to infinity. That means this signal amplitude does not become zero, or it not become zero when t tends to infinity. At any instant, its amplitude will not reaches to zero value. Hence, it is a characteristics of a periodic signal. So, for a periodic signal, the amplitude is not become zero when t tends to infinity. And the second is the energy of this signal has a value infinite. If such cases is found for a signal, we defined another parameter that is called average power. That means for a signal, if its energy is not measured, then we check it or we find it is power. So when the energy or the average, that means the power is, and the power is calculated on the average value, not the total power. So for a real signal, average power will be calculated as P equals to limit t tends to infinity 1 by t minus t by 2 2t by 2 x square t dt. So it is the condition, or it is the expression for a power signal. Recall the concept that if a signal has infinite energy, that means its energy cannot be defined, then we can measure its power, and the power should be the average power. And the expression for calculating power or average power be this. If it is a complex signal, then the expression would be, this is for real signal. If it is a complex signal, then just like the previous case, the value will be mod of x square t dt for a complex signal. So it is for real signal, it is for complex signal. Now, the example of a power signal is a periodic signal. From this fact, we can say that almost all type of periodic signal are the example of power signal. If we compare between an energy signal and a power signal, then there is a chart. So, our next topic is comparison between a power signal and a energy signal. So, in the left side, you write energy signal, and in the right side write the power signal. Then one by one it is observed, all the characteristics of these two signals are observed. So the first will be total energy of a signal. Total energy represented as E of a signal will be finite. And non-zero value. For a power signal, average power, not total power, it is average power of the signal is represented as P, is finite and a non-zero value. Number 2, the average power of a signal will be 0 for an energy signal. That means if a signal xt is an energy signal, then its average power is equal to 0. For the power signal, if xt is a power signal, then its energy will be infinite. Not it is 0, it is infinite. Third comparison, the energy will be calculated as minus infinity to infinity mod of xt square dt. For a power signal, the average power will be calculated as limit t tends to infinity 1 by t minus t by 2 to t by 2 mod of xt square dt. Fourth one, example of energy signal will be all type of non-periodic signal. For a power signal, example of power signal will be all type of periodic signal. Obviously, there are some exception for both cases. That means for such typical kind of non-periodic signal, it should not be a energy signal. Similarly, if that means some power signal or some periodic signal is periodic in nature, but it should not called as a power signal. But they are the exception. For most cases, all the energy signals are non-periodic nature and all the power signals are periodic in nature. Let's we solve some problem related to this. So there is a problem to you. Sketch the following signal xt is equal to a sine t for minus t exists minus infinity to infinity. It is your problem. So there is another question. Also check whether the above signal is an energy signal or a power signal. So we can see from this expression that the signal is xt equals to a sine t. So that means from this expression you can see, or you can easily understand, that the signal is sinusoidal in nature with a maximum amplitude a. If a is written before sine t, that means it is the maximum amplitude of that signal. If we plot that signal, it would like, so if we plot the signal said that xt is equal to a sine t then it would like this. Why? Because you can see here it is the maximum amplitude, so I write here a, and as it is a sinusoidal signal, the signal will be looks like this. Now for a sinusoidal signal, the signal value start from 0, that means the amplitude start from 0, and the shape of the signal is after when the time t equals to pi, 0 to pi, that means it's time when t equals to 0, the signal will be 0. Again the signal will becomes maximum for this value, and it is again becomes 0 for t equals to pi value. Then the signal again it is increasing, but for the negative time, or this negative that means quantity, that means it is a and it is minus a. So again this signal will exist for minus value, and again it becomes 0 up to when t equals to 2 pi. After that the same thing will repeat it. So therefore it is 2 pi by 3, then the second interval will be the 3 pi. So by this way the signal will be represented, a sinusoidal signal can be represented. Now from this figure we can easily say that it is a periodic signal, and hence its energy will be infinite. So as you already know that for a energy signal or for a periodic signal, the energy will be infinite. Let's we find its average power. So as the energy will be infinite, so we have to calculate the power. So for calculating power, you have to consider the previous formula. The fundamental period of this signal will exist from minus pi to pi. So this is the fundamental time period. This is the fundamental time period, because you can see here this shape of the signal is repeating for throughout the time. That means again this signal, the shape of this signal is again repeating for this interval also. Again for this interval also, the signal shape is repeated. So therefore its fundamental period is this, from this to this. So it is minus pi to pi. So its fundamental time period, it will be minus pi to pi. So I can write here minus pi to pi, that means 2 pi. So consider the formula for calculation of power signal. So formula will be P equals to limit t tends to infinity 1 by t minus t by 2 to t by 2 x square t dt for a real signal. So as it is a periodic signal, so that means it is a, so you can see here the signal is represented as a sine t, so it is a real signal. So therefore we can consider this formula. If it is a complex signal, then it should be, we represent the mod value. So now put the value of t and the expression becomes limit t tends to infinity 1 by 2 pi t equals to 2 pi. Therefore I write here 2 pi minus pi to pi, because t by 2 as it is 2 pi, therefore pi or 2 is cancelled, therefore it is 1 minus pi to pi, and xt is equal to a sine t, therefore it is a sine square t dt. So it is our value. Now we represent the constant term outer side of the integration. So it becomes minus pi to pi sine square t dt. So it is our next term. Then we write here, from here, so we can write here limit t tends to infinity a square by 2 pi. You recall a formula, sine square theta equals to 1 minus cos 2 theta. It is your formula is there in your HS syllabus. So recall that and use this formula. So the formula will be, here becomes minus pi to pi 1 minus, you cannot see here, so I have to write here. So here p equals to limit t tends to infinity a square by 2 pi half it is represented by, why? Because I can here write 2 sine square. The formula is there will be 2 sine square theta equals to 1 minus cos 2 theta. It will be your formula in your that means trigonometric formula used in ages. So this formula is used here. So it is sine square t dt. Again I am right here a square by 4 pi one minus cos 2t dt is equal to, again just do the for maths part, and after breaking the integration term it would become So here it will be a square 4 pi t minus pi to pi and a square by 4 pi, because a is this term is common to this, so it would be sine 2 theta by 2 minus pi to pi. Again up to this, and then we have to just put the value of pi. So after value of pi is by putting, we can see here minus pi to pi half sine 2t minus pi to pi a square by 4 pi. It is pi to minus pi, that is plus pi, because first term is pi, again minus of minus pi, that is plus pi, and this will be sine 2 pi plus of sine 2 pi. Again it is a square 4 pi, it is 2 pi, and it is 1 by 2 sine 4 pi. A square 4 pi. So here sine 4 pi value is equal to 0. Therefore this term is omitted. So only here we can write a square by 4 pi into 2 pi. Now pi is cancelled. It is also cancelled. So our answer will be a square by 2. It is our desired answer. And it is, as it is a finite and non-zero value, therefore the condition for power signal is satisfied. So this is all for this lecture. See you in the next class. Thank you.